RLC, everybody's favorite. Is it any much more harder? No. No. Just got a couple extra steps, that's all. RLC, number 5 and number 6. But, before we do that, bandwidth. Bandwidth, what is that? What is bandwidth? That's it, that's all you gotta know. Bandwidth, definition, a range or group of usable frequencies. Does that have to do with this lesson? You need to know the definition of bandwidth. It's in your handout, you got notes, I just told you. There was something else that was introduced characteristic-wise for RLC, which is what? Or was what? Resonant frequency. Remember that? What is this infamous resonant frequency? What is that? What is it? What is resonant frequency?
It's the point where the net values of the individual components will cancel each other out. So they have a zero voltage drop or zero power drop.
Okay, I like it. Everybody hear that? Sir. We all did practice today, right? Sir. And didn't you all get to actually see it before your very eyes? The series RLC circuit, X sub C, X sub L, or VCVL cancel out. At the center frequency or resonant frequency, you achieve maximum power in a circuit. The reactive components cancel out, and your circuit is purely what? Resistive. So, we're going to get to this in a minute, a few minutes, but based on what I just stated, you should have been able to determine between these 3 different frequencies in this circuit, these given values, where you achieve maximum power, which component is operating above or below resonant frequency, or more capacitive, more inductive. Yeah, I'm going to ask you those questions when we put all these answers up, and I'll show you what I'm talking about. But you should have been able to determine that. Number 5, series RLC. Characteristics, not much. Bandwidth, resonant frequency, not very much. But here's the thing with this. It's nothing different than RL or RC circuits by themselves, is it? Except now we have to find net values. X for series, X net, V net. And what does that mean? Just basically take the difference when you might be asked that, hey, given this series RLC circuit, V net equals blank. What do you got to do? Solve the circuit to get to that point where you can find it. You can't shortcut it. Just solve the circuit. It doesn't take much to solve it. It's not a big deal. But you have to do this on the exam. You got to be able to do this. So if you're still a little fuzzy on RLC circuits, after I go over all these with you, then you know what you need to do tonight. You need to seek additional help from roommates or military instructors, something. So here we go. Here's where we're at, number 5. Finding XL, XE, XNet, Z, all this stuff, isn't it? It's pretty straightforward, isn't it? There's no tricks to this. We did the lesson, we did examples, we had homework, we did extra things, and here's some more. So wherever we left off, let's roll with it. Number 5, series RLC. XL1, that's what I got up here first. What's the answer? XL1.
94.25 ohms.
Close enough. I got 94.28 ohms, 25, close enough. And if anyone's having any trouble, now would be the time to say something. XC1. Answer, keep going, whoever's next.
3.98 ohms.
Yeah, I'll buy that. 3.98 k ohms. Okay. XNet, just take the difference. Take the difference. XNet equals what? Where's that?
I said it was 3.89 k ohms, but for XC1 I got 3.99 k ohms.
XC1, 3.99K, that's what I have. K ohms. XNet, 3.9,
3.89.
or 8.9, what is it, round up to 9?
Yes, sir.
Okay, so, yeah, they're pretty similar, because look at the CXL and XC, if you take it, yeah, it's gonna be like close, so that's okay. Whoever, who is that? Oh, okay, yeah, you're okay, that's fine. But 3.89 is like 3.89, something higher, 5 or higher on your calculator? Was it? Basically what I'm saying, we're good. That's basically what I'm trying to say. We're good, it's okay, it's okay. Gold star. Happy now?
Yes, sir.
Okay. Z-Total, next, Mr. Kelly.
3.95 K ohms.
And I got 3.96, close enough. 3.9596, and it's not that big of a deal. I total.
7.59 milliamps peak to peak.
Good. Ohm's law to find these voltage drops. VR1, next.
VR1 is 5.33 volts peak to peak.
All right, I'll buy it. 5.33 volts peak to peak, that's pretty good. Pretty good. Next, VR1.
715.36 millivolts.
Point what?
0.36 millivolts peak to peak.
Okay, close enough. Millivolts, that's very important. Yeah, millivolts peak to peak. Do I got an issue with that one? Just Ohm's law here. VC1, next.
I actually have like 303.8.
Yeah, go ahead and try again. What'd you get for I total? Did you get this? 7.59 milliamps?
Yes.
Okay. And XC, 3.99K or something close to that, just multiply them together.
I have 30.21.
Yeah, that's good. I like it. 30.21, I've got 2.4, that's pretty close. Volts, and it is that unity, peak to peak, just like that. All right. VNet.